Welcome back everyone. It's Thursday 9 p.m. KSA time, and like always, it's time for another ETABS journey. Now imagine this with me. You have just finished modeling the very first floor of your building. You have placed the columns, beams, slabs, everything looks great. But then you stop and think, wait a second, do I really have to model the second floor, the third floor, and the 10th floor all over again? That would be like painting the same picture again and again, tiring and time consuming. But here is the good news. ETABS has a smarter way. Today I'm going to show you how to duplicate floors. It's like telling ETABS, hi, I have built one floor, now copy it as many times as I need. And just like that, your entire building begins to rise before your eyes. And that's not all, we will also take a look at the results. Because at the end of the day, the model isn't just about drawing lines. It's about understanding the behavior, the loads, and the responses of our structure. So stay with me, and by the end of this lecture, you will know how to save time, avoid repetitive work, and get accurate results for your project, all with just a few smart clicks inside ETABS. Without further ado, let's get started. So here we are. This is our model from the last tutorial. If you remember, we have already assigned the loads to our structure. Everything sits on the first floor and looks pretty solid. But of course, this is not just a one-floor building. We need to complete the remaining floors. And instead of redrawing everything from scratch, we are going to let ETABS do the heavy lifting for us. Think of it like building with Lego. Once you finish one block, you can just stack it up again and again. That's exactly what the replicated option does for us. So now we will quickly replicate these floors, watch our building rise floor by floor, and then the exciting part, we will move on to see the results, because modeling is just the first half of the story. The real magic is when we check how the structure actually behaves under the loads we assign. Let's jump right in and start replicating our floors. The first thing you need to do, just select the whole structure. As you can see here, 21 joints, 31 frame, 1 shell, 4 edges. Make sure that here is one story only, and then go to edit, replicated. For sure you will select here story. Now we are here in the story 1, which is the ground floor. This, as we said, it's just for the foundation or to assign the support. So we will replicate it to story 2 and story 3 and 4. So we will not select story 1 here. We will select story 2, story 3 and story 4. While selecting, press on Ctrl on the keyboard so that you can do multiple selections. Now, just click on OK and watch the magic. Apply, and here we are. This is our model. Click on OK. Now we are ready to check out our result. So all you need to do before that, if you want to see the 3D view of your model, just click here. And from this menu, click here on Extrude. So this is our model. And now to check out the result, just go to display, show tables, and from here you should go to analyze. But oh my god, there is nothing here, and that's because we haven't done run. So just close this. As you can see, the lock is still unlocked. All you need to do, just click on this button, run analysis. So after running analysis, we got this message showing 3 warnings and 1 information and 0 errors. And that's okay, no problem with that. I want to make something clear. This model was not created for real design purpose. I made it only to teach you the steps inside the ETABS. That's why you see more warnings here. And that's perfectly fine. The goal of this video and the previous one is simply to help you understand how to use the software and what the workflow looks like, not to deliver a final design. In the next video, inshallah, we will start with a real project model from scratch, and we will go through the steps properly so that we don't get this warning. So for now, keep in mind this, it's about learning ETABS, not designing a real building. So just click here on OK, and to see how the model behaves, just click here on this start animation. What you need to see from this animation is that everything is linked together. Means like you don't see this column flying away by its own, or this one all moving together. But as you can see here for now, this column isn't moving, and that's why we got a warning message. See, as you can see, the whole building is dancing up and down, and this column is just standing upright. And that's wrong. It's supposed to move up and down. But as we said, it's not any issues, because these videos were just to show you how the workflow will go on. But as you can see, the slabs are okay, beams are okay, these columns are okay. See this one, he's standing like this. So just click here on the story animation. Now to check out the result, as you said, go to display, show tables, and here we have analysis result. Go to joint output, reaction, and click on OK. And here this is our joint design reaction. This table, which we need before we start designing columns and foundation. For now, we will just talk about it. Make sure that here all story based. If you find that story 1 or story 2, that means you are working wrong. Means that you have assigned the support in the first floor or second floor mistakenly, and this will cost you a wrong output. So make sure this all is based. From here we can see the loads cases. We have dead load, life load, and model, and etc. What we need for designing columns, we need the ultimate load. So just right click, and from here select ultimate, and this unique name, it represents the column position or the column labeling. So come here to plan views. Okay, no issues, I'll show you later on. That's because this window is open. Here we have unique name 6, 8, 10, 12, and this is represent the labeling of columns to know which column and its reaction. And what we need also from this table, we don't need this fx, fy, we just need fz. And about the moment, since it's not an earthquake design, it's just a simple project design with 4 floors. That's why we don't have moment. You can see it's only 0, 0, or you will find small negative values. And all you need just now, fz. So from here, right click and check off what we need, unique name and fz. That's what we need from here. So as we said, here we have the results. For now, what we really need to take from this analysis is the fz value in the ultimate case. That's the key point at this stage. In the upcoming videos, I will teach you how actually you can start designing step by step, and we will go much deeper into the process. But for now, I just want you to understand how to get these values and also how to read and recognize the column labeling inside ETABS. Once you are comfortable with that, we will be moving into the design part, which will be much easier. So for now, just memorize that. Here we have unique names 6 and 8 and 10. Now close this window. How to know the labeling for columns? Just click here on plain view, story 1, go to the base, and here from display, go to object assignments. So as we said, go to object assignments, and here from joint assignments, we will click here on labels. Click on apply. So here we are, these numbers represent our columns. So as we said, we have column number 6, which is this one, 8, which is this one. So close this one, the display, the tables, click on OK. From here, make it ultimate. It's this one, column number 8, this one, and so on, number 10. So that's it for today's video, and with that, we can say we are done with our ETABS introduction series. Now you can work with ETABS more easily, doing the steps, the workflow, and some of the important tricks. In the next video, we will begin a brand new journey, diving into the structural design process, starting with the statical system. That's where we will connect what we have learned here with real engineering design. Do not forget to like, subscribe, and share this video with your friends. Thanks for watching. See you in the next video, inshallah.